Hey everyone, so we are beginning the trig unit. I actually just recorded this whole entire video without pressing the record button, so I promise it will be short and sweet because I worked really hard and I don't want to be here anymore. So trigonometry, guys, is just the study of triangle measurement. Okay, and hopefully you can kind of tell that is what trigonometry means. Your hint is the word trig and metri. So metri in Latin, that's a Latin root for measurement. Trig is triangle. Okay, so we are given trigonometric ratios, sine, cosine, and tangent. There's actually 6, but these are the 3 that they introduce in our course. Okay, and sine is the ratio of the leg opposite the angle to the hypotenuse. And I'll put a comma here because I feel like it deserves it. Okay, so the ratio means that it's going to be a fraction, and sine of A means sine of angle A, right? So this is angle A over here on the left, our picture. And if we are referencing angle A, the leg opposite angle A is this little A here, side AB. CB, sorry. Side CB is our opposite side. And then, of course, our hypotenuse is side length C. So sine of A is A over C. Now, if we're finding sine of sine B, okay, it is opposite angle B over our hypotenuse, C. Okay, so sine of B is B over C. So it really depends on which angle you're referencing to determine the sine, right? And sine is going to give us a side length. That's what we're going to use it for in questions 4 through 11. So cosine, guys, is the ratio of the leg adjacent to the angle to the hypotenuse. So the ratio of the leg adjacent to A, right, because we're finding the cosine of A, well, adjacent means next to, right? That's what we learned about adjacent angles. Adjacent angles share a common right. So next to A over the hypotenuse. So that would be cosine of A is B over C. Now from angle B, okay, our adjacent side would be side A. So that's A over C. And then finally, we have our tangent. Okay, and tangent is the ratio of the leg opposite the angle. So if we're talking about angle A, because we're finding the tangent of A first, opposite the angle would be side A. To the leg adjacent to the angle. Well, again, referencing angle A, what's next to A is B, right? So we have opposite over adjacent would be A over B. And now finally, tangent. Okay, we're tangent of B, tangent of angle B is opposite over adjacent. So that's B over A.
Good afternoon, members. We do have one bus replacement this afternoon. If you ride bus M60, please look for bus number 1333. Have a wonderful day.
The bell's about to ring. Sorry, guys, I'm not stopping the video. So we have a way to remember this, okay? And I mentioned it today, and you guys looked at me like I had 3 heads. It's SOHCAHTOA. Okay, and so what that means is sine is opposite over hypotenuse. Okay, so I'll write that in. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. and it's going to make a lot more sense once we start applying numbers. Okay, so we are trying to find the angle measures in this case because they give us sine of A, cosine of A, tangent of A, right? And if we were trying to solve for A, we would just plug in our calculators given the sine lengths. So I'll do number 1 and 3. You guys can do number 2. And remember, for the first half of this, I'm referencing angle A. So sine is opposite over hypotenuse. So that's 5 over, well, what's my hypotenuse? The hypotenuse is 13, so 5 over 13. Okay, and if this was a triangle, and we were trying to find our angle, right, which we could do, I would get out my calculator, make sure it's in degree mode. Excuse me, guys. All right, so that would have been much faster if I was a doll, but definitely not as fun. All right, so if we're trying to find the angle, right, we use the inverse function and plug in our 5 divided by 13. Okay, and I'll press inverse sine, right, and so that angle measure is actually 22.6, which is like a preview of what we're going to be learning tomorrow. So that's how this is used. Cosine, remember, is adjacent over hypotenuse. So adjacent to angle A is 12, right? So cosine of A is 12 over 13. Okay, and tangent is opposite A over adjacent to A. So opposite over adjacent is 5 over 12. All right, so we're half done with number 1. I will leave that 13 is the hypotenuse because the hypotenuse doesn't change. Only the opposite changes, and the opposite and the adjacent change. Now we're referencing angle C. So for angle C, opposite is now 12. So 12 over hypotenuse, 13. Okay. So cosine is adjacent over hypotenuse. So adjacent to C is 5 over the hypotenuse, 13. Okay, and tangent, opposite over adjacent. So that's 12 over 5. Okay, and you want to leave them improper but reduced. Okay, number 3. So it looks like they gave us 2 sides, not the third side, which obviously we're going to need to find. So let's go ahead and find that real quick. I don't know if I'm able to put it all in at once. If I have 34 times 34, okay, minus 16 times 16 is 256. Okay, the square root of 900 is 30. So this side length, km, is 30. So sine of L, opposite over hypotenuse. It's 30 over 34, and we'll reduce it. to 15/17. Cosine of L, okay, so that's adjacent over hypotenuse, 16/34, which is 8/17. And finally, tangent of L is opposite over adjacent. So 30/16 reduces to 15/8. All right, so same thing, but now from angle M. Here's angle M. Sine is opposite over hypotenuse, so 16/34, 8/17. Cosine is adjacent over hypotenuse, so 30/34, 15/17. Okay, and tangent is opposite over adjacent, so 16/30, which is 8/15. All right, so these are kind of impractical questions. You will almost never just be asked for the ratios, right? We only use trig to find what we need, so missing angles or missing sides, right? So here, we're going to apply it. And I'll do the left side. Okay, you guys can do the right side. Try to remember SOHCAHTOA. All right, that's going to help you determine which trig function you're going to use. So we're given an angle, the hypotenuse, and okay, in reference to 28 degrees, this would be opposite, right? So you're asking yourself, which trig function has an O and an H? Okay, so that's sine. So we use sine of 28 degrees equals opposite over hypotenuse. Okay, and to solve for x, we treat it like a algebra problem, meaning we're going to just eliminate the 19 by the divided by 19 by multiplying by 19 using the inverse function. So that is x equals 19 times sine of 28. So on my calculator, I'm going to do the sine of 28 first. So I'll type in 28 sine. Okay, that gives me the sine of 28. And then I'm going to take this number and multiply it by 19. So x is 8.9. So number 6, we're given the hypotenuse, our angle, and the adjacent. Okay, so you're looking for a trig function that has an a and an h, which is cosine. So we're going to do cosine of 21 equals a, which is x, over h, 26, adjacent over hypotenuse. So same thing, right? We multiply both sides by 26 to eliminate the x being divided by 26. And we're left with x equals 26 times the cosine of 21. And I'll take the cosine of 21 first. 21 cosine times 26. And how you use your calculator might be different from this, but that's okay. 24 I forgot it already, 24.3. Okay, so that is my longer leg, 24.3. What? Units? Feet or inches or something. Okay, so number 8. We're given our angle, we're given the hypotenuse, and in reference to our angle, this would be opposite. So hopefully you guys are getting used to this now. You're looking for a trig function with an O and an H, which is sine, right? O and H. So sine of our angle, 33, equals opposite, 15, over hypotenuse, x. Oh, all right. So this one's different. We have to get x out of the denominator. So if we're getting x out of the denominator, I'll multiply both sides by x. Okay, so
Ms.
x
Levy, can
times
you please
sine
dial 33423?
of 33 equals 15. Now I'm still trying to get x by itself, right? So I have to divide both sides by the sine of 33. Okay, sine divided by 33 divided by sine of 33 is 1. So that's how you get x by itself equals. Okay, so I'll do 15 divided by parentheses 33 sine equals 27.5. Okay, so number 10, now we have an angle, the side opposite the angle, and the side adjacent to the angle, right? So this is an A. This is my hypotenuse, right? They don't let us use our hypotenuse at all. So which trig function has an O and an A? That's TOA, right? So that's tangent of my angle, 72, equals opposite, 25, over adjacent, x. So this is another one where my x is in the denominator. So I have to get it out. I will multiply by x on both sides. Okay. So that's x times tangent of 72 equals 25. And then divide by tangent of 72 on both sides to eliminate our tangent of 72. We get x equals 25 divided by tangent of 72. So again, 25 divided by parentheses 72 tangent and parentheses is 8.12, so 8.1. All right, and now we have our word problem. The challenge question says Jake leaned a 12-foot ladder against his house. So here's the side of his house. There's his roof. Okay, I'll make it a little bit longer. Here's my ladder. And the ladder's 12 feet. The angle formed by the ladder and the ground. So that's this one here is 68 degrees. Here's the ground. And how far from the base of the house did he place the ladder? All right, so the base of my house is going to be here, right? So I'm looking for my horizontal distance. So here we go. I have the hypotenuse. Hopefully you can tell that pretty easily. And next to my angle 68 is the adjacent. So cosine of 68 equals adjacent over hypotenuse, x over 12. Multiplied by 12 on both sides, and x equals 12 times the cosine of 68. Okay, and 12 times the cosine of 68, 68 cosine times 12 is 4.495, so I'm going to say 4.5 feet. So x is 4.5 feet. All right, so I think that was like 15 minutes. Might be a record. All right, good luck and good night. I'll see you tomorrow.